fabricate a particle of the size of 1 nanometer. My question is, sir, we have fabricated 1 nanometer. How you can say, sir, the size of the particle is 1 nanometer? See, 1 nanometer means very small. We have a device, students. You know, you have learned something like microscopes in your basic classes. But remember, the microscopes, what you talked, you know, it is their optical microscopes. Optical microscopes means what? You know that you will have a lenses, okay, converging and diverging lenses. You are going to use the radiation, okay, and you know resolving power of optical microscope. All those things you have studied. But do you know what is the magnification produced by optical microscope? Very less, students. 100 times. Definitely, when you talk about this nanoparticles or when you talk about this nano-sized particles, these optical microscopes are of waste. You cannot. Then what happened? You know, today we have a better microscopes. I think you people have heard about this. Electron microscope, scanning electron microscope, tunneling electron microscope, atomic microscope. Okay. It is scanning electron microscope, SEM. We call it as SEM. Electron microscope. What do you mean by this, students? Okay. See, electron. How can this electron beam can function of a light? Surprising thing, no? Definitely. You know, students, when these electrons are made to move with a very high velocity, remember, electrons are treated as particles. They are treated as waves. You know that it is proved actually. When a beam of electrons are made to fall on a gold foil, they will undergo diffraction, electron diffraction. So they used that. Okay, that is okay. Then how can you converge this beam? How can you diverge this beam? Students, they came up with, okay, and they are called as magnetic lenses. Field and electric field. They were able to diverge, converge, made the beam parallel. Okay. So all these devices, what I am telling students, they require electronic basics. It may be vacuum, it may be producing magnetic field. Okay. So if you see all these high-end devices, because of these microscopes only today, you know, all this, you know what, certain diseases we are able to overcome, students. Today, if you go to a doctor, they will just take a pinch of your blood and they will see microscopes, and they will come to know. Yeah. Yes, so every field, whether it may be medical, whether it may be any instrument, students, definitely there you need the idea of, you know what, electric field as well as what, magnetic field, electromagnetism. You all know, students, your branch is existing today. It is because of Maxwell's equations. Definitely, you may be thinking, sir, we have learned, sir, in plus 2, we have learned electric, we had so many chapters, sir, we have learned. See, whatever you have learned, as I want to say, everything is duplicate because he used classical mechanics. Okay, but definitely not correct. So, quantum mechanical perspective, what will happen? So, again, this magnetism. See, when you talk about magnetism, definitely a lot of interesting things will come. What I want to discuss today. As I told you, students, we are just going to do interconnection. Okay, because that's what we can cover in our syllabus. Okay, because you see, for this module, what they have told, you know, if you see the given time, they have told that properties of these materials and superconductivity, I have to complete. That means you people should know. 4 hours means you should have a backup knowledge, students. See, that is the difference between your plus 2 and what, engineering. Here, no teacher will tell you the backup. Okay. See, since we are basic science people, we are going to tell few things. But once you go to branches, you should have a previous knowledge. See, they cannot make you teaching you basics, you know. Time is very less. You people should have a basic. Suppose if you don't have, you know, some of you, okay, you have got a good mark, but you may not have that basics. So definitely you have to do self-study. We try to explain whatever the basics required for you. We try to understand Suppose if time is not sufficient, I may take some. But students, you people, you people should understand. Just a minute, I will upload a PPT. Okay, you people should do some work. Definitely, lot of effort you have to put. Okay. Try to understand. That's what I want to say. See, don't worry about your CGPA and all. Definitely, some of you will be thinking, what sir, you are telling like this? 7.5 above, good. But I have seen students. One semester full, you will study many subjects. Once the semester is completed, you people will not remember even a bit of what you studied. See, why we need that type of education? At least, see, you learned 19 PHY 103. At least 40% of this should be permanently there in your mind. Okay, so that is what I wanted to say. Okay, with that, let us enter into the module. So definitely, some of you may face the problem, students, because entirely the mode of changing. Okay, reason I will tell you. You are in +1, +2. There, 1 year time they used to get, but here, 36 hours. We have to complete 36 hours syllabus. We cannot keep on solving 20 numerical, students. So keep this in mind. Okay. So especially my classes, whenever you are in my classes, you have to have a book and pen. Okay. Whenever I am telling, you have to write down. You have to write down what I say. It is like a regular class. Using that as a base. Okay. You have to prepare the notes. Definitely, I'll give a supporting textbook for you. I will tell. Okay. In a simple way, I will try to explain. Okay. But you have to follow. If you are not sincere, if you don't follow, definitely it will be difficult. Why? Because ours is a semester system and ours is a continuous evaluation system. Keep it in mind. Okay. So don't think that we will give like this questions like this: what, or define, or explain, or nothing like that. Okay. Whatever we teach in the class, based on that, questions will come. If you have understood, if you are regular, if you are following a teacher, it will not be difficult for you. Okay. So with that, I wish you all the best. Okay. So let me share you a PPT and let me explain you. So I am sharing my screen. Yeah. Just a minute. Using a gadget. So I want to write. Okay. 1 minute, students. 1 minute. Is just a minute. Just teaching you like as you know in the regular board exactly I will be teaching so that you have to note down the things, students. Just a minute. I will just yeah. You are able to see my screen. My video I will switch off. Are you able to see see the PPT?
Yes, sir.
So I will switch off my video, students.
Yes, sir.
Yes, sir.
It may. Okay. Okay. Let us go on. See, let us go to this module. Okay. So what are the things we are going to study here? Okay. The heading of this I have given as magnetic materials. So in this magnetic materials, so you may be thinking, sir, we have learned this, sir, in +2. Yes, we have learned. Okay. Only certain things I am going to explain. Okay. Little bit in a higher order, that's it. Okay. I can say you have learned in level 1. I will just take you to another one level, that's it. Okay. So what you are studying in this? Okay. We are studying little bit of history. Definitely, students. See, history plays a very, very important role. Is it? Okay. See, remember, this is very, very important. Whatever you study, students, you should know the history of that. Little bit. Okay. Yes. Next. Magnetic dipole moment. Here, certain things I will make you understand. Definitely, people have studied. That only I will elaborate a little bit so that it is like a revision for you. We are going to study about that magnetic dipole moment. Then classification of magnetic materials. I am going to classify this types of magnetic materials and how they are classified. Okay, in little bit higher order, we are going to understand this. And we talk about these two. See, these two things are very, very important. Permeability and susceptibility. You know that. Permeability. When you talk about electric field, permittivity will come. So permeability and susceptibility, students. So all these things, according to them, I have to finish in two. It will take some more time, not a problem. Then this is the new thing, students. Saturation and Curie temperature, these two things plays a very, very important role in magnetic materials. And last but not least, superconductivity. So this superconductivity, lot is there. I will try to compress everything, okay, and I will just try to give it superconductivity. Okay. I'll give some leads also for you. If anyone is interested, you can study further. Okay. Yeah. Let us go to the next. This is the what I am going to. So let us recap. Recap means keep it in mind. You people have already learned this. Okay, I'm just trying to bring this back. You know this, students. Okay, magnetism. See, if you go to the history, we know that this was discovered or identified by the people long back, 600 BC itself. You know the story behind that. Okay. Again, it will take us to Greece, a small island which is called as Magnesia in that Greece, where some shepherds, they went. See, I want to say you students, people they knew about metals long back. Even if you go to Dwapara Yuga, already they were using metals. So the shepherds, they had a stick, wooden stick. Okay, at the bottom of the wooden stick, they had a metal ring. Okay, and even they were wearing a wooden slippers which has got iron nails. When they went to some place, they were rearing the sheep everywhere. When they come to some particular place, they observe that something is pulling them. They are not able to lift their leg up. They are not able to lift the stick. So these people got worried. They thought something is there. Some devil is there here, or some super power is negative energy is there here. So they ran. But after some time, when they came again with some people and they started searching why this is happening like this. And when they dig at that place for some distance, they observed that there are certain rocks. Today we call them as magnetites or lodestones, Fe3O4. They observed that these stones have got that property. Okay. Basic observation. They came to know that they have got this property, and they came to know that these stones will attract only certain selected metals. Okay, like iron and alloys of the iron. And they came to know that this stone will not attract the wood, or many other materials. See, at that time, people were ajnanis.
So the stone used in Somnath temple is lodestone, sir.
That only.
Oh.
The fundamental name of that is lodestone. That chemical name is this Fe3O4. Okay. Then, then actually at that time nobody bothered about this students. Yeah, leave. What is that? Then, as the people, generations went on, people started thinking, see, why this metal have got this property? See, they were not able to understand why, because at that time they didn't have a knowledge. Even they didn't know about atom itself, right? The concept of atom came in 1802. They are not, they are not bothered about all those things. But few things, what is that is, when they took this stone, okay, when they took this, okay, so this I have already explained. When they took this stone and when they tied this like this with a piece of a thread, and when they suspended, They observed that this stone used to come and it used to stand in one particular direction. You know that. See, initially they were not knowing the reason for that. So therefore, what they did is the side of the magnet, the side of the stone, which is north pole, they called it as north pole. Okay, the one which is towards geographical south pole, they called as south pole. This was the basic explanation. Okay, because they didn't knew the reason why it is standing. Okay. So they told us. So let us go to the next. These are all things you know. I want to tell you this. Then this property came into picture. They observed that if the like poles are brought nearer, they are repelling. South and south repelling, north and north repelling. And it is observed that unlike poles, they are what? Attracting. See, long back itself, they observed all these things. But they are not able to explain this. That's it. So another one very, very important. 1 minute, please. Something happened. Yeah. See, this is very why because you know if you go to electric field, see by that time, see even before people understood this magnetism or magnetic field, they understood electric field. They understood electric field first, okay. Then they understood magnetic field. Then they started thinking, can we produce magnetic field from electric field and electric field from magnetic field? It happened in 20th century. You all know that. Then only this current, AC current, all those things came. Okay. See, magnetic monopoles do not exist. What do you mean by this? Okay. What do you mean by this? Let me explain. Okay. See, you know that if you take a charge, you can get plus Q. Okay. Or if you can get minus Q. You can get this separately. You can get this separately. Okay. So electric poles exist. Okay. But if you come to this magnetism means, students, see, you know that you have a magnet. Okay, this is a north pole and this is a south pole. If you break this, again each piece will have north and what? South. Keep it in mind. You break this into 1,000 pieces. Each piece. My question for you is: can any one of you, with your basic knowledge, can you tell why? Any idea? No. I will explain later on. Don't worry. Okay. See, when I ask anything, if you know, you tell. Even if it's 100% wrong. Okay. Even if your answer is 100% wrong, no issue. Who is this? Some symbols and all you are sending? Don't do all those things. Okay. Even if your answer is 100% wrong, don't worry. Whatever you know, you tell. Okay. I will value your answer. The chart and all I cannot see, students. Okay. If you chart anything when I am talking, I cannot see. Okay. You can tell it. So one thing you remember, in case of magnetism, magnetic monopoles, you know what? Do not exist. See, some people are doing some nonsense. Don't do all those things, students. Students, yeah,
Yes.
you identified who is that doing. Okay, someone has raised his hand. Yeah, tell me. Pavan Pampana. Okay, okay. Let me go on. I will answer this question later on. Okay, and another one very important is students. Okay, just a minute. So another one very important thing is later on what people came to know is itself is behaving like a magnet. You know that. See, today we can say all these things in fraction of minutes. But to understand these things, see why Earth is behaving like a magnet. And you know what are the parameters, okay, relevant to the magnetic field of the Earth. Time it took. Earth itself is behaving like a magnet, and they came to know that actually what they called as North Pole, that is towards magnetic South Pole of the Earth. What they called as South Pole, that is towards magnetic North Pole of the Earth. Okay. And another one small thing I want to make you understand from the recap is, students, what is that is, just a minute, I will just, okay. You are not able to see. Are you seeing anything, students, now? In the PPT, it's not coming, right?
No,
No,
sir.
sir.
Yes, sir.
White.
No, sir.
No, sir.
No, sir.
1 minute.
It's a blank screen.
Yeah, it came. Okay.
Yes.
I'll give the answer of what is this? See, we don't have. Yeah, just a minute. I am using one small pen, that's why no issue. See, if you take any magnet, students, if you take any magnet like this, if you take any magnet, this is the South Pole and this is the North Pole. What it is observed is the magnetic field is stronger at the poles, and it is observed that the strength of the poles will be same. Keep it in mind. If you take a given magnet, the strength of both the poles will be what? Same. Again, this may be a reason why. Why the strength? Why we cannot get a magnet with a different pole strength? That we will see. Okay, I will explain this. I will bring in, okay, the concept of electrons for this. So this is a simple representation of a magnet. Okay. Now let us enter into the syllabus. So I will always take the reference of the concept of electric field. Students, electric field came first, Coulomb's law, Gauss law, all those stuff came. Then similarly, magnetic field, here Biot-Savart's law, Ampere's circuital law, even Gauss law also came here. You can identify the similarity if you have studied. Okay. But only thing is, in electric field, monopoles exist, poles does not exist. See, my question is, see, I have written one diagram here. Whenever I put arrow mark like this, and if I write E on that, on the top, if I write, so as soon as I write electric field, immediately you know that, students, this side it is plus and that side it is minus. You all know. And you know the reason for that. The reason for that is, students, I will tell you. Okay, to understand electric field, we have taken a positive test charge. Okay, today all the definitions are defined by taking positive test charge only. Even electric potential, everything. You cannot change anything now. In the same way, students, okay, field also, even though monopoles does not exist, magnetic field is understood by taking an isolated north pole. It's a so you know that if there is electric field, plus q and minus q, two charges which are equal in magnitude and opposite in nature will come into picture. And you all know, students, two charges which are equal in magnitude, opposite in nature, separated by a distance d means that constitutes electric. That means what I want to say is, students, if there is an electric field, that means there is electric dipole. Okay. See, if there is electric dipole, means there should be electric dipole moment. You know that. Okay. P is equal to Q into D. Normally you studied like a Q into 2L. See, why I told this? Because see, you can go reverse also, students. Actually, in magnetism we are going reverse. What reverse? There is a magnetic dipole moment. If there is a magnetic dipole moment, there will be magnetic dipole. If there is a magnetic dipole, there should be magnetic. Okay, it's like this. So, if there is electric field means you should know. In the same way, if there is a magnetic field means all this stuff will come into picture. So let me show you. This also I have taken one small diagram. See, Keep it in mind, student. See, on the top you can see the diagram. Okay, that magnetic field and all I have given. Keep it in mind, students. Keep it in mind. Always magnetic lines of force outside the magnet, it will be from north pole to south pole. But we are not dealing with that. Magnetic field means lines inside. Always they are from south to north. Keep it in mind. Just a minute, I will show you here because otherwise you will get confused. Yeah. So let me write. See, this is what I am telling you. Okay. This is what I am telling. So whenever I write like this, and if I indicate B, you people should know this is south and this is what north. You have learned this, but again, it is my duty to tell. Okay. See, I am just showing you here. See, I am writing B like this means. Okay. You people should know. 1 minute. It just didn't go for you. Just a minute. Some lagging is happening. Yeah, it came. So whenever I put a arrow mark, this is very important because as I go on, all these things I will be using, then you should not have any confusion. That's why fundamentals, if you know, if you have understood, then afterwards you will not have any confusion. Okay. See, if and if I write like this, B means it is a magnetic field, and definitely this side will be south and that side will be north. Okay, this side will be that side will be north. Okay, and the pole strength here, students. Okay, this is also M, that is also M, that is also M, pole strength, and dipole. See, south and north, two poles which are opposite in nature and of same magnitude separated by a distance. So all the we are going to study in this magnetic materials, it will be based on this magnetic moment. Okay, this is the basic equation of magnetic. Okay. Yeah. Now let us move on. Now I am entering. See, we all know that students in the +2, in some chapters, you after understanding the charges, what happened? First, you understood the charges which are at rest. After understanding the charges at rest, then you people started thinking. What you started? Okay, can we make the charges to move? Point number one. Point number two, what will happen if the charges are made to move? Yes. Then people started thinking in that side. And they started thinking how to make the charges to move. That also they understood. Electric potential came into picture. They came to know that you can make the charges to move by applying electric. Then what happened, current came, all those stuff came. But another important thing what people observed is, students, when the charges are made to move, see, this credit should go to Oyster, right? When the charges are made to move, it is producing magnetic field. That means people came to know that from the electric field you can produce magnetic field. You have a charge, apply the electric field, make the charge to move. Once the charge is made to move, it is producing magnetic field. Okay. A charge which is in motion produces magnetic field. See, people have learned. Okay. See, actually what happened is, students, when they observed this, by the time they had not even understood that magnetic materials. See, they used to see that some materials used to attract, and they also had observed that some materials kept in contact with the magnet, they used to get magnetized. But why all these things? See, at that time they didn't have any knowledge of all those stuff. But because of this, when the charge is made to move, it produces a magnetic field. No, see, this helped the people to understand all those stuff. Why? Because see, until this happened, see, I can say this happened. What is this? What is like that? Approximately after that. By the time they are using permanent magnets in applications. Okay, but there are some disadvantages of this permanent magnet. Definitely, very important, but there are some disadvantages. You know that first of all, it is heavy, and again the magnetic field. You cannot vary the magnetic field, and again, as the days goes on, the magnetic field decreases. Lot of problems. So when they observed that charges which are in motion produces a magnetic field, they started thinking, why cannot we use this? Electromagnetism concept came, but they came to know that if you make the current to flow in one straight conductor, the magnetic field, we are getting a magnetic field, but you know that, okay, uh, its magnitude is different at different points. You know that, right? And class rule, something you have learned. Then they started thinking, what will happen if the current is circular path? This is the striking fact. You all know, students. Okay, when the current is okay, I will just write you here one small thing. Let me explain. Okay, just a minute, students. Yeah. So what it is, see, when the current is made to move in a circular path like this. So keep it in mind, students. Here I am talking about the current. This is the current. Okay. So this diagram I have given for that reason only. When the current is made to move in a circular path, they observed that magnetism comes into picture. Okay, it is existing magnetic field. So this concept they took it out. See, whenever you talk about electron, you know that. Just a minute. And above. Okay. Yeah. There is some lag, students. Okay, no issue. There is some lag between my yes. So this is the striking thing, students. See, after this only, people, they started understanding this magnetic metals. They were able to explain why certain metals exhibit this magnetic property and why certain metals can be, and why, see, wood, glass and all, you cannot convert them into magnet. Okay. After this observation itself, they learned all those things. So let me explain now in a simple way. See, we know that atom, you take any atom, students, it has got electrons. See, forget about nucleus. Even if you want to study in depth, even nucleus also you have to take, because even in the nucleus, charged particles, they will not be at rest. They will be moving. Okay, that is also charge is motion. No, see, take about electrons. You know that, students, electrons will be revolving around the nucleus. We all know. And another thing, you have studied all the atomic models and all. You know that, students, which is the atomic model which explained this atoms. It is vector atomic model. First Thomson's atomic model came, it went. Then Rutherford's atomic model, it went. Bohr's atomic model, it went. Okay. Then another one, it was given by, what is that? 1 minute, I forgot his name. Okay. Uh, Spatial quantization. See, what he says is, he says that electrons revolve around the nucleus in elliptical orbits. Okay, so that also failed. His name also I forgot. Then finally, vector atomic model came. Vector atomic model explained. See, what vector atomic model introduced is, it says that, see, the electrons which are revolving around the nucleus, they are not revolving in only particular path, in one particular direction. Okay. Okay, they are having their path around the nucleus is different. See, in the diagram I have shown, no, like that. Okay, and again,
So the vector atomic model is like the extension of Bohr's model only, right?
yeah. Okay, it's the extension. So we call this as spatial quantization. Okay, and again, another very important thing, what is introduced by vector atomic model is spin. You know, students, that spin itself is playing a very important role, right? So because of that spin only, Mr. Pauli's exclusion principle, and this, what we say, quantum free electron theory, it is entirely based on that Pauli's exclusion principle. See why I told this, because see, I have an atom, student. I have an atom. Okay, we know that, as I told you, Okay, a charge which is moving in a circular path produces a magnetic moment. Check out here. I have just given here. Just a minute. I will show you in pen. See, you can see here. You can see here. Okay. But here, very important thing, students. You should be very careful. See, one diagram I have given here. This is just to make you understand what is the direction of the magnetic field. And this is for positive charge. Keep it in mind. See, check out here, students. Electron is moving in this direction. So current is flowing in the opposite direction. We know the direction of the current is always opposite to the direction of motion of electron. Okay. So you have to hold your hand in such a way that, okay, current is moving like this and you have to indicate the magnetic field. Okay. So that is a very important. So what is that you can see here is, yes. So see, because of this, when I erase this, there is a lag, students. Okay. No issue. I will just rectify it. Just a minute. Just a minute. It will go away. When I do erasing, this will happen. Okay. Yeah, it went off. Very good. So what is that I want to say is, an electron revolving around the nucleus, definitely it produces a magnetic moment. You can see there I have represented M is equal to I into A. This is the new thing. Under this case, definitely atoms should exhibit magnetism. But you know that, students, because of the spatial quantization, I will show. Yeah. So what is that is, see, one electron will be going like this. It will have a magnetic moment like this. Another electron will be going like this. It will have a magnetic moment like this. Another electron will be going like this. It will have a magnetic moment like this. So net magnetic moment will be what? 0. Okay. This is because of spatial quantization. And another thing what I want to say is, and if you go to any level, you know that according to Pauli, students, according to Pauli, you know that one energy will be accommodating 2 electrons, and the speciality of this electrons is one will have up spin, another one will have down spin. Okay, one will have another one will have down spin. Okay. So here also what will happen, students? Net magnetic moment is what? 0. Okay. So keep it in mind. Majority of the atoms, what we are observing, the net magnetic moment will be what? 0. Okay. So with this, we are starting our topics. Till now, I have not entered the topic, students. Just I was explaining you the basics. Okay. So let us come to, if you take atoms, so we have electrons. See, all the matter in this universe, it is made up of atoms. So we have electrons. And students, whenever we talk about electrons, you should know, as electronics people, you are very much interested in conductors and semiconductors only. In conductors and semiconductors, the electrons, what we are talking is outermost electrons. The electrons in the outermost orbit. Okay. But if you take the electrons which are in the innermost, they are always paired, right? And one energy level, if it will have 2 electrons. But only when you come to, what is this? Okay. Only when you come to electrons which are in the outermost orbits, they may be paired or what? Unpaired. So this they observed. Paired and unpaired. Okay. This outermost electrons which are in the outermost orbits, which are paired, they are playing a very important role in this magnetic property acquired by the material. Okay, so by taking this paired and unpaired itself, I am going to talk about 2 types of materials, students. Okay, and even these 2 types of materials are waste. You cannot use them to produce magnetism. Okay, and third type material they understood. Then you may thinking, sir, why we have to understand, right? Okay, see, whether it is a insulator means we should know why it is an insulator. Conductor means why it is a conductor. This is what we have done. And again, in superconductivity, some of the properties of this materials will be useful to us. Okay, So today I have just introduced. Why I didn't touch the topic, because students, after this class, I will be just coming whenever as a fill. Okay. Once sir completes the syllabus, then only I will come to this. Why? Because he finishes 3 modules, then I will come at the end. Why I do this? Because another teacher will be teaching EAC. Okay. Because for T1 and all, they have to give the same question paper, right? So it is just like a filler. Okay. Whenever I get the classes like this, okay, I will try to explain. I will try to explain you, students, certain things and keep it in mind. Okay. When I start again, I will revise all. Okay. So that's it, students. With that, I am just stopping my class. Okay. See, if you have any questions, anything like that, always you are welcome. Okay. You can chat with me also. Okay. When you chat with me, any doubts and all, you can message me. I will help you out in your doubts and all. Always feel free to talk to me. Yeah. So you have another one class now, students?
Yes, sir.
Yes, sir.
Okay, okay. Today I have not talked anything. Just I talked some basics. Okay. Actual syllabus. I will. Okay, students. Take care. Bye. See you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.